Compound inequalities. So today we're going to take and put more than one inequality together. So it says more one inequalities together and ask what x values make both, okay, true, and which make either or the other true, which is or. So it's just like a compound sentence. And a compound sentence has two parts, and you could join those two together by the word and, or you could join them together by the word or. It says, and you deal with and or along with truth values, okay, for the remainder of algebra. So let's see what we're talking about here. It says, consider the following compound, meaning more than one inequality statement. So when we take something simple that we are familiar with, so that first one, it says 7 is greater than 3. Well, we know that's true. And 2 is less than 10. We know that that part of it's true. So that makes the whole compound inequality true. Looking at part B, and it says 5 is less than 10. We know that's true. And, okay, 11 is greater than 20. Well, we know that that's false, so it makes that whole compound inequality false. Look at part C. Negative 4 is less than 7. We know that's true, but now my connector is or. Or 8 is less than 2. We know that to be false. So now, because it says or, true or a false, it makes that whole compound inequality true, just by changing the word there, just by changing that connector. 3 is greater than 6. We know that's false. Our connector is or. And 8 is less than 5. We know that that's false. Connecting it, if we have a false or a false, it's still making that whole statement false. So some of you are probably shaking your heads and you're like, excuse me? So let's take another look at it. And it says, most students would correctly judge the truth values of the 4 examples above correctly. But there is a strange disconnect in math between our use of the word or and the way it is used in the real world. So I always try to come to this example. Okay. So if you and your parents are having a conversation and it's you want to go out with a friend, okay? So going out with a friend. That's what you're discussing. And your mom says, in order to go out with your friend, you must clean your room or empty the dishwasher. So what are you going to have to do in order to go out with your friend? That's right, you're going to have to pick one or the other. You don't have to do both. So one could be true, you could clean your room, and then the other could be false. You don't want to empty the dishwasher and you still can go out. Or maybe you want to empty the dishwasher is true, and then cleaning your room is false, but you still can go out with your friend. But if both of them are false, you didn't clean your room, you didn't empty the dishwasher, are you going to be able to go out with your friend? Heck no. So now let's change one word there. Same idea, going out with your friend. And now, what if your mom says, and? In order to go out with your friend, you have to clean your room and empty the dishwasher. So you're like, all right, sure, I'll clean my room, but you're like, I really don't want to empty the dishwasher. Are you going to be able to go out with your friend? No. Okay, you can't. You didn't satisfy both pieces there. Okay, both pieces of the deal. Same thing, flip it around. Didn't empty the dishwasher, okay, or you cleaned your room. Are you going to be able to go out? No. But if you do both of them, both are true, are you going to go out? Sure. If you don't do either one, are you going to go out? No. Okay? So that's that slight difference between and or. With or, only one piece has to be true in order for the whole statement to be true. But with and, you have to fulfill both situations, okay? Both have to be true in order for the whole compound inequality to be true. So if I take and apply some math to that, so I've got a true or 4 is less than 1. That's false. It's or, so that's going to make that whole statement true. 10 is greater than 0 is true. Is negative 3 less than 9? That is true. My connector is or, so that's true. Negative 6 is less than 5. We know that to be true, but now my connector is and. Is 7 greater than or equal to 7? Well, yes, that's true because it's equal to. So true and a true, yep, that's true. Negative 2 is less than or equal to 4. That's true. My connector is and. 5 is greater than 7. Is 5 greater than 7? That's false, but your connector was and. Go back to that idea of cleaning your room and emptying the dishwasher. You did one part, but you didn't do the other, so that whole statement is false. Okay. Going on, it takes that idea and now it summarizes it. Okay, all nice and mathematical. Okay, I summarized it by using that example of cleaning your room and emptying the dishwasher, or cleaning your room or emptying the dishwasher. So whatever works for you. This is real mathematical right here. I gave you something kind of concrete to remember the difference between and or. So as we continue, we need to address the idea of solution sets of equations and inequalities because they determine the truth value of that equation or inequality. So it says a value of a variable is in the solution set, okay, in the solution set of an equation or inequality if it makes it true and is not in the solution set if it makes it false. So that's where we bring that truth value into our inequalities or equations. Okay? So it says, determine if each of the following values of x is in the solution of the compound inequalities given below. So we've done sort of these basic ones already on the front page, A and B. So let's look down, do the same thing, but now we've got a little bit more complex here in C. So it says, determine if x is part of the solution set. So now we look at our connector and we have and. Okay? So I take it, it says justify. So our justify is going to be taking that 1, substituting it in to that first part of our inequality, and then taking the 1 and substituting it in to the second part of the inequality. And now let's determine both truth values. So we have, this gives us 11 is greater than 9. We know that's true. Keep in mind our connector is and then this one gives us 8 is 8 less than 7. Well, that's false. So what does that say about this whole compound inequality as a whole? Okay, it's false. So is 1 part of the solution set for this compound inequality? No. Okay. Let's look at D right next to it. Now we're taking, is 5 part of this inequality? So let's examine what our connector is. Let's do our substitution. So I'm substituting 5 in. And then I'm saying 10 minus 1, that's 9. Is 9 less than 3? That's false. Our connector is or. Now I have 12 divided by 2 is 6. Is 6 equal to 6? That's true. False or a true makes that entire inequality true. So if the entire compound inequality is true, is 5 part of the solution set? Yes, it is. Okay, true, part of the solution set. False, not part of the solution set. So let's graph these. Okay, let's graph these solution sets on the number lines below. So with this first one, x is less than 7 and x is greater than or equal to -2. So it says list out some values. All right. So I like to go right to the number line and graph each piece. X is less than 7. So I know 7 is here. It doesn't say equal to, it just says less than. So it's an open circle. And it's less than, so we know that less than is going to go to the right. But because I have the word and in there, now I've got this other piece. So I'm going to think about my graph going this way for that first piece. And x is greater than -2, so greater than or equal to. So we're going to fill it in on -2, and where are all the values of x greater than -2? Now remember, it's and, so it's got to be true for both of them. So where are they true for both? Just right in between those two. Okay, so some values that would make both of them true. If we picked, say we picked 0. Okay, 0 is showing up as right in between those two. If I tested it in the first one, is 0 less than 7? It's true. Is 0 greater than or equal to -2? That's true. A true and a true makes my whole statement true. So I've graphed it correctly. So part B, I've got 5 and x is greater than 5. That's I seem to be going that way. Or x is less than -1. Open circle, less than to the left. Look what's happening. So list some values. Remember, because it's or, it only has to be true for one inequality or the other in order to make the entire thing true. So if I picked 6, is 6 greater than or equal to 5? That's true. Or is 6 less than -1? That's false, but because it's or, one or the other makes that whole compound inequality true. Okay. Let's move ahead to the next lesson. Okay. So some more work with inequalities, compound inequalities. And let's see what this first one says. Okay. Graph each compound inequality on the number lines provided. For C and D, write the inequalities as a single statement. Well, I want to start with C and D. Okay. So I'm going to graph this. So it starts off and it says that x is greater than -3. 1, 2, 3, open. Greater than is going to go this way. But I notice my connector is and, so it's got to be true for both. So an x is less than 5. So remember, it has to be true for both. So it ends up being all of those points in between. So how do I write this as a single inequality? Because right now I have two separate inequalities. So we start off with, just like we would read this from left to right, so we go from least to greatest. And all of my values of x lie in between. So I would say 3 is less than, -3 is less than x, which is less than 5. So if we kind of pick that apart, look at this. X is less than 5. Ooh, look at that. X is less than 5. And now pick it apart the other way, but read backwards. Is x greater than -3? Oh, look at that. X is greater than -3. So this is how you would write this as a single inequality. This is the most popular way to write the and inequality, okay, the and compound inequality. You very rarely see it written like this, or has to be written as two separate inequalities, but and can be written as one single inequality. So let's do that one more time. X is less than 9, less than or equal to 9. Okay, so it's going to come this way. It's and, so it's got to be all the values in between. Remember, they both have to be true. So at 0, x is greater than or equal to 0. Greater than is going to go to the right, so that's where they're going to meet in the middle. Notice your and inequalities will always meet in the middle. Your or inequalities will always go in opposite directions because it's either or. Writing this, start off with our least, which is 0, less than or equal to. All the values of x fall in between, and it goes all the way up to and including less than or equal to 9. All right, let's move on. So this right here just addresses, okay, that and are just about always written as a single inequality. Okay. So we could split these two up, okay? They're saying split them up. Generally, we don't have to do that, but I'm going to show you one of them. Take it and go the opposite way. So we could say that x is greater than or equal to -4, and now the piece that I circled or I boxed in the purple, x is less than 6. Okay, so splitting that up, you would still graph that. We would look at our two end points, -4 up to 6. It's and, so it's everything in between. Okay. For each of the following graphs, write a compound inequality that describes all the numbers shown on the graph. So looking at this one, it goes in opposite directions. So automatically, I know it's an or inequality. So I look and I read this graph, and I would say that x goes to the left, less than, it's an open circle, and what is it less than? -1. Or, now let's continue on, we read it from left to right, and I would have x is greater than or equal to, because it's filled in, and where does it start? It starts at 5. So that is an or inequality. This one, notice that it's shaded in between. That has to be an and inequality. Start reading it just like we read from left to right. So that's at -8. It's an open circle, so it's less than. Keep in mind, we're going to write this as a single inequality, so all the values of x fall in between the two values. So I come up to my next value, and it's an open circle, so less than 1, 2. So if your mind is doubting you right now, break it up. X is less than 2. Is that true? Yes. X is less than 2. The values are going to the left. And then take out that other piece. Remember, you got to read backwards, read from the variable. Is x greater than -8? Yes, that is true. Okay. Go ahead and let's flip that over. Let's jump down to part B. So we're given this compound and inequality. And it says, solve the compound inequality and graph its solution on the number line below. So now, what do? I've got this compound inequality. Treat them individually to solve them, and then we're going to graph the solution to that whole inequality on the graph below, because we treat them separately, but they are one big compound inequality, so they are one problem. So I'd start and I would subtract, and x is greater than or equal to 3/6, or we know that to be 1/2. And then over here, and -2x is greater than -20. Oh, let's be real careful. So I'm dividing by a negative. We learned last lesson why that happens. Okay, we've got to switch the direction of the sign where x is less than 10. So I go to my graph and I say, okay, it's an and inequality. Both situations have to be true. All the values of x are going to fall between 1/2, okay, which is right here, 1/2, and it's equal to, and 10, but it's going to be an open circle on 10 because it's not equal to, it's just less than. So x is less than 10 is going to come to the left, And then x is greater than our 1/2. That goes to the right, okay, confirming that we shade in between. Okay, and let's hop down to 5b, and then we'll be done. So let's take this compound inequality. Notice it's an OR inequality, so keep in mind what happens with an OR inequality when we graph it. They're going to go in opposite directions. So 1/2 the quantity x plus 4 is less than 5, or -2 the quantity x minus 4 is less than or equal to 14. Solving that, so we distribute 1/2 x plus 2 is less than 5. 1/2 x is less than 3. I'm going to multiply by 2 on both sides. X is less than 6. Or, now let's go over here, distribute plus 8. -2x, I'm subtracting it. I'm not showing my work because I'm running out of space here. Is 6. Divide by a negative. Again, make sure you flip the direction of your inequality symbol. Let's put our values on here. X is less than 6. So open, less than 6 is going to go to the left. X is greater than -3. 1, 2, 3, greater than or equal to, holy smokes, what's happening here? I could pick any number on this number line. Notice arrow to the left, arrow to the right, everything is filled in. What could we say about the solution set for this inequality? All real numbers would make it true. Okay, make it true. We have an infinite solutions to this one. Okay, make it true. Nice job.